While the voltage difference between the United States and European electrical systems, 120 volts versus 220 volts, can potentially lead to more severe shocks, several factors contribute to the lower incidence of electrical accidents and fires in Europe compared to the United States. Firstly, European countries have stricter electrical safety standards and regulations. These standards govern the design, installation, and maintenance of electrical systems, ensuring a high level of safety. For example, in the United Kingdom, electrical installations must comply with the British standard BS 7671. This includes detailed requirements for wiring, circuit protection, and grounding. Secondly, European systems typically employ better grounding practices. Proper grounding provides a low resistance path for fault currents to flow, reducing the risk of electric shock and fire. Additionally, European systems often incorporate more sensitive circuit breakers and fuses, which trip more quickly to disconnect power in case of a fault. Thirdly, European wiring practices generally use higher quality materials and more robust construction methods. They often employ sheathed cables, which provide better insulation and protection from damage. In contrast, United States homes often use non-metallic sheathed cables, which are more susceptible to damage and can lead to electrical hazards. Fourthly, European building codes typically require the use of fire-resistant materials and construction techniques. This reduces the risk of electrical fire spreading. Fifthly, some argue that cultural differences may play a role. Europeans may be more aware of the potential dangers of electricity and take more precautions. Additionally, Europeans may have a greater respect for authority and are more likely to follow safety regulations. It is important to note that the number of electrical accidents and fires in both the United States and Europe has declined over time due to improved safety measures and increased awareness. However, the lower incidence in Europe can be attributed to a combination of stricter regulations, better wiring practices, and cultural factors. Exploring further into grounding and circuit protection, in the United States, the National Electrical Code, or NEC, sets the standard for electrical installations. However, the implementation and enforcement of these codes can vary by jurisdiction. In Europe, standards like the International Electrotechnical Commission, or EIC, standards are widely adopted and often more rigorously enforced. Grounding is a critical aspect of electrical safety. In a properly grounded system, if a fault occurs, such as a live wire coming into contact with a metal enclosure, the fault current will flow through the grounding conductor back to the source. This high current causes the circuit breaker or fuse to trip, quickly disconnecting the power and preventing a dangerous shock hazard. European systems often use equipotential bonding, which connects all exposed metal parts to the grounding system. This ensures that there are no voltage differences between different metal surfaces, further reducing the risk of electric shock. Residual current devices, RCDs, also known as ground fault circuit interrupters, or GFCIs, are widely used in Europe. These devices monitor the current flowing in the live and neutral conductors and quickly disconnect the power if there is an imbalance, indicating a leakage current to ground. This is highly effective at preventing electric shocks. Turning to wiring practices, the types of cables used and the methods of installation can significantly impact electrical safety. European wiring standards often mandate the use of multi-core cables with a separate grounding conductor. These cables are typically installed in conduit or trunking, providing additional physical protection. The insulation materials used in European cables are often of higher quality and more resistant to heat and abrasion compared to some of the materials used in the United States. In the United States, non-metallic sheathed cables, or NM cables, are commonly used in residential wiring. While these cables are relatively easy to install, they are more vulnerable to damage from nails, screws, or rodents. If the insulation is compromised, it can create a shock hazard or a fire risk. Furthermore, European junction boxes and electrical fittings are often designed with better insulation and protection against accidental contact with live parts. This reduces the risk of electric shock during maintenance or repairs. Looking at building codes and fire safety, European building codes often place a strong emphasis on fire resistance. Materials used in construction, such as walls, floors, and ceilings, are required to meet stringent fire resistance ratings. This helps to contain a fire and prevent it from spreading rapidly. Electrical systems are also designed to minimize the risk of fire. For example, circuit breakers are required to have both overload and short circuit protection. Overload protection prevents the wiring from overheating due to excessive current draw, while short circuit protection quickly disconnects the power in the event of a short circuit. Fire-resistant cabling is also commonly used in critical applications such as emergency lighting and fire alarm systems. These cables are designed to maintain their integrity for a specified period of time during a fire, ensuring that essential safety systems continue to function. Examining cultural differences and safety awareness, in some European countries, there is a greater emphasis on education and training related to electrical safety. Electricians and other tradespeople are required to undergo rigorous training and certification programs. This ensures that they have the knowledge and skills to install and maintain electrical systems safely. Public awareness campaigns also play a role in promoting electrical safety. These campaigns educate people about the potential hazards of electricity and how to prevent accidents. Furthermore, there may be a greater cultural tendency in Europe to follow rules and regulations. This can lead to better compliance with electrical safety standards and a lower incidence of unsafe practices. It is important to recognize that the United States has also made significant strides in improving electrical safety over the years. The NEC is regularly updated to reflect the latest advancements in technology and safety practices. GFCIs are now widely required in areas where there is a high risk of electric shock, such as bathrooms and kitchens. Arc fault circuit interrupters, or AFSIs, are also becoming increasingly common. These devices detect arc faults, which are a common cause of electrical fires, and quickly disconnect the power. Despite these improvements, the United States still faces challenges in reducing electrical accidents and fires. One challenge is the age of the existing electrical infrastructure. Many homes in the United States have older wiring systems that do not meet current safety standards. Upgrading these systems can be expensive and time-consuming. Another challenge is the lack of consistent enforcement of electrical codes across different jurisdictions. This can lead to variations in the quality of electrical installations and an increased risk of accidents. In conclusion, while the voltage difference between the United States and European electrical systems is a factor, the lower incidence of electrical accidents and fires in Europe is primarily due to a combination of stricter regulations, better grounding practices, higher quality wiring, fire-resistant building codes, and cultural differences. By learning from the best practices in Europe and continuing to improve safety standards and enforcement, the United States can further reduce the risk of electrical hazards and make homes and businesses safer.